Alright, so in this video, we're gonna go over the chain rule. The chain rule. And basically, the chain rule says if you have something like f of g of x and you want to differentiate it, then you have f dash. So you differentiate f of the function f with respect to g of x. So you get f dash g of x, and then you differentiate the function, the inner function. So now I know this may not make sense at first when you look at it directly, but here is this question that I want you to ask whenever we are going to do questions related to differentiation. Whenever you take the derivative, this is a question you want to ask. And it's in Dzongkha, in English, it's was it x? Right? So that is the question. In Dzongkha, it's okay, this is going to sound funny, but ani x ina. Okay. Ani x ina. So ani x dega or ani x ina. And you're gonna see why this is important. I know it's sort of hilarious that I'm writing this, but this is a question that you want to keep in mind when using the chain rule. Alright. So ani x ina or ani x dega, that is something I'm gonna I'm gonna be asking you a lot in this video. And while we do differentiation in general. So ani x ina or ani x dega, that is going to be very important. And ani x made zewajin, you're going to differentiate it again. Okay, so this is probably the only video where I speak Dzongkha. Hopefully not, but okay. So ani x ina or ani x dega is the question we're going to ask. Alright, so differentiate with respect to x. So I'm going to do all the odd number questions, so like B, D, F, H, J, L, and I'm gonna leave the even questions to you. So A, C, sorry, the odd questions here, I'm gonna do the even questions. So I'm gonna do B, D, F, H, J, L, and I'm gonna leave A, E, I, C, G, K for you. All right. So the first question is I want to find the differentiation of 2x plus 3 to the power 8. So now, how do you start this? Well, you use the same rule that I gave you, right? D by dx of x to the power n is nx to the power n minus 1, right? So you're going to use this rule again. So you know that if you differentiate this, you're going to get 8 2x plus 3. So 8 comes to the front. You have 2x plus 3. And then 8 minus 1 is 7. Now you ask the golden question. Ani x dega. Was the stuff that you're differentiating ani nanagi x dega? No, that was not x, ani x made. And made zewajin, you want to differentiate it again. So you differentiate 2x plus 3, the inner function. So you differentiate f, remember, f dash of x with respect to g of x, and then you differentiate the g of x function, right? G dash of x. So when you differentiate this part, you're going to get 2, right? Ani x dega, the formula, so remember, d by dx of x to the power n is nx to the power n minus 1. So this formula only works if your function is x, involves x, right? But now lubewachin, it's not x, it's 2x plus 3. Ani x dega, ani x made. So you use the rule with 2x plus 3, but you have to remember that you need to differentiate 2x plus 3. Ani x made zewachin, you differentiate it again. So now you have 8 2s 16, 2x plus 3 to the power 7. So that is your solution. And let me turn on my laptop real quick so I can compare answers as I go. Yeah, 16 2x plus 3 to the power 7. So that is B. Alright, so now I hope you get why I'm using Dzongkha, and hopefully things are starting to make sense. So now let's do this, right? So d by dx. I'm so sorry about that. Okay. Half x plus 1 to the power 9, right? So you just use the rule. 9 half x plus 1 to the power 8 times ani x dega, ani x made. So you differentiate it again. Half x plus 1. So you have 9 half x plus 1 to the power 8. And if you differentiate the second part, you get half. So now you have 9 over 2 half x plus 1 to the power 8. So that is your solution for D. All right, let's do f. So we're done with d, so I'm going to erase this here. And I'm going to do f here. So f is 5, 2x minus 1 to the power 5, right? All right, so now let's differentiate. D by dx of 5, 2x minus 1 to the power 5. So 5, you can bring it to the front, right? If there is a constant multiplying a function, you can bring your constant to the front. 2x minus 1 to the power 5. 5 times, differentiate this. You get 5, 2x minus 1 to the power 4. But ani x tega, ani x made. So you differentiate it again. All right, so you have 5 times 5 is 25. 2x minus 1 to the power 4. And then when you differentiate it, you get 2 here, right? If you differentiate this, you're going to get 2. You get 50, 2x minus 1 to the power 4. So you have 50, 2x minus 1 to the power 4. That is the solution for f. For h, is the same thing. So, okay, let's do h. H is 1 over 5, 3x minus 1 to the power 7. So if you differentiate it, 1 over 5, 3x minus 1 to the power 7, you can take out 1 over 5, d by dx, 3x minus 1 to the power 7. Now you do your regular process, right? 7, 3x minus 1 to the power 6, but ani x tega, ani x made. So you have to differentiate it again. So whatever was not x, you differentiate that. So you have 7 over 5, 3x minus 1 to the power 6, and then when you differentiate it, you get 3. So you get 21 over 5, 3x minus 1 to the power 6. All right, so that is h. Now j. So I'm going to erase this. I hope that is okay. So j is 2 minus x squared to the power 8. So you want to differentiate this. You do the regular thing. So 8, 2 minus x squared to the power 7. But ani x tega? No. This is 2 minus x squared. So you differentiate 2 minus x squared. Ani x made. Was this x? No. So now 8, 2 minus x squared to the power 7. And when you differentiate this, you get minus 2x, right? This derivative is 0. You keep the minus, and then when you differentiate x squared, you get minus 2x. All right, so you get minus 16x, 2 minus x squared to the power 7. That should be your solution. So j, we are done. I, you do it in the same way. E is also the same. You just have 1 over 4. And 5x minus 2 to the power 8. So it's very similar to f, but instead of having 5, you have 1 over 4. All right. And then L is just d by dx of x squared minus 5 over x to the power 5. So now you differentiate it once, right? 5 x squared minus 5 over x to the power 4. Ani x tega, ani x made, right? So you differentiate it again. Whatever was not x. So 5 x squared minus 5 over x to the power 4. And then when you differentiate it, you get 2x minus 5 plus 5 over x squared, I think. So if you differentiate this, and I'm going to leave that as an exercise. You differentiate the first part, you're going to get 2x. You differentiate the second part, you're going to get, so you keep 5, you get minus 1 over x squared, right? And minus minus will give you plus. So overall, you're going to get this expression. And when you put 5 inside, you're going to get 10x plus 25 over x squared. And you have x squared minus 5 over x to the power 4. So that is your solution for the last one. Okay, let's see how the textbook expresses it. Okay. So the textbook expresses this answer a bit differently. So they have 5, right? X squared minus 5x, sorry. You can write this as x4 minus 5x over x squared, right? Let's see. No. That's not how they write it. Okay, so let's just first of all make them have a common numerator. So that is x cubed minus 5 over x to the power 4. And here we have 2x cubed plus 5 over x squared. So you have x cubed minus 5 to the power 4, 2x cubed plus 5, and then you have x4 times x squared. So this combined will give you x6. So this is how they have simplified. But remember, it's the same answer. All right, so we're done with question 1. So I'm going to leave A, E, I, C, G, K for you. And for the second question, I'm going to do A, C, E, G. Okay. So differentiate with respect to x. So I have d by dx of 1 over x plus 2. So that is going to be d by dx. I can write the second part as x plus 2 to the power minus 1, right? And now you do minus 1 x plus 2 to the power minus 2. Ani x tega made, so you differentiate it again. And when you differentiate x plus 2, you're going to get 1, right? So times 1. The times 1 is not going to make a difference. So you have minus 1 over x plus 2 squared. All right, so we're done with A. And usually, if you just have x plus some constant, then your derivative is just going to be x plus some constant. So you can use the same rule as you did with x if you have x plus some constant. But you can't use that if you have, say, 2x. Then the chain rule will yield a different answer. All right, so you have d by dx of 8 over 3 minus 2x, right? You can factor this 8 out. And you have d by dx of 1 over 3 minus 2x, which I can write as 3 minus 2x to the power minus 1. So 8, you bring this minus 1 to the front, you have 3 minus 2x to the power minus 2. But ani x tega, ani x made. So you differentiate it again. Minus 8, you have 3 minus 2x to the power minus 2. And when you differentiate this, you get minus 2, right? And then overall, you have 16 over 3 minus 2x squared. So that is going to be your solution. Yep, 16 over 3 minus 2x squared. That is going to be your solution here. Let's do E. So I'm going to erase this. So E is going to be d by dx of 4 over 3x plus 1 to the power 6. So you can take the 4 out, and d by dx of 3x plus 1 to the power minus 6, right? So you factor out your 4, you bring your 4 to the front, you have 1, and then you can write this expression as this. So 4, you bring minus 6 to the front, 3x plus 1 to the power minus 7. But ani x tega made, so you differentiate it again. So 3x plus 1. All right. So you have 24, 6 4s are 24, 3x plus 1 to the power minus 7 times 3. And if you do this, 3 4s are 12, 1 3 2s are 6 plus 1 is 7, negative 72 divided by 3x plus 1 to the power 7. That is going to be your solution. And finally, we're going to do G. You have 8. You want to find the derivative of 8 over x squared plus 2x. So you can find the derivative of 8. You factor out the 8. You have 1 over x squared plus 2x. And actually, you can write this as x squared plus 2x to the power minus 1. So now, when you do the derivative, you get minus 1 x squared plus 2x to the power minus 2, right? You bring this minus 1 to the front, you have x squared plus 2x to the power minus 2. But ani x tega, no. So you have to differentiate this again. So 8 times minus 1, x squared plus 2x to the power minus 2, and then 2x plus 2. So now you get minus 8 times 2x plus 2 divided by x squared plus 2x squared. And do we need to simplify this inside? I think not. I think you can simplify it as minus 16 x plus 1. That is how, so you factor out the 2 from this term. So you have minus 16 x plus 1 divided by x squared plus 2x squared. And that is your solution. g. All right, so we're done with question 2. Question 3. So I'm gonna do the even questions again. B, D, F, H. Okay. So question 3a is d by dx of 2x plus 3, right? And I can write this as d by dx of 2x plus 3 to the power half. Now we can use the same rule. This is going to be half. Bring your power to the front. 2x plus 3, half minus 1 is minus half. But ani x tega, made, so you have to differentiate 2x plus 3 again. And you will see that you get 1 over 2, 2x plus 3 to the power positive half. I really encourage you to see how you go from this to this, right? And when you differentiate this, this is 2. And this 2 and this 2 are going to cancel out. So actually you have 1 over square root of 2x plus 3. That is going to be your solution. B. For D, you have d by dx of square root of x cubed minus 5x. So you want the derivative of x cubed minus 5x to the power half. Now you can bring the power to the front. X cubed minus 5 minus half, right? That is the standard procedure. You take the power to the front and you subtract 1 from the power. So half minus 2 over 2. 1 is just 2 over 2, right? Half minus 2 over 2 is minus 1 over 2. But ani x tega, made, so you differentiate it again. This ani x made me. And this is 3x, x cubed minus 5x. So now you do this. And you get divided by 2 x cubed minus 5x to the power half. And then when you differentiate this, you get 3x squared minus 5. So overall, your solution is 3x squared minus 5 divided by 2 square root of x cubed minus 5x. That is going to be your solution. So let's do F. F is just d by dx of 2 square root of 3x plus 1. So your function is the term that contains the x part, right? So this part contains the x. This is a constant multiplying your function, so you can bring out your constant. So now 2 times d by dx of 3x plus 1 to the power half, right? And now when you do the derivative, you get 3x plus 1 to the power minus half. Ani x tega, made, 3x plus 1. So you want to differentiate 3x plus 1. So these cancel out. You get 3x plus 1 to the power minus half times 3. So 3 over square root of 3x plus 1. That is your solution. And finally, you have h. So d by dx of 6 over 2 minus 3x to the power. Cube root is just to the power 1 over 3, right? You can factor out the 6. And you get 2 minus 3x to the power minus 1 over 3. And now 6 times, you bring the power to the front, 2 minus 3x. If you subtract 1, so minus 1 over 3 minus 1 is minus 1 over 3 minus 3 over 3, right? With the same denominator. And you will see that you get minus 4 over 3. But ani x tega, made, so you have to differentiate it again. Alright, so you get minus 2 here. You have 2 minus 3x minus 4 over 3. And when you differentiate this, you're going to get minus 3. So overall, you get 6 over 2 minus 3x to the power 4 over 3. And the textbook prefers to write this as the cube root of 2 minus 3x to the power 4. Whichever is fine. This is also the same thing. So we're done with question 3. All right. Moving on to question 4. Find the gradient of the curve at the point where the curve crosses the y-axis. That just means x is equal to 0. The curve crosses the y-axis when x is equal to 0. So we want to find dy by dx is going to be just apply d by dx to 6 over x minus 1 squared, right? So you bring your 6 to the front, d by dx of 1 over x minus 1 squared. And remember, I can just write this as x minus 1 to the power minus 2. is 6. You bring your minus 2 to the front, x minus 1 to the power minus 3. But ani x tega, made, so it's x minus 1. So you have to differentiate that as well. But when you differentiate this, you will see that you will just get 1. So you have minus 12, x minus 1 cubed. And you want to substitute x is equal to 0 here. So you get positive 12 is your answer. Question 5. You want to find the gradient of the curve at the points where the curve crosses the x-axis. So that means y is equal to 0, right? If your curve is crossing the x-axis, you want to solve for 0 is equal to x plus 2, right? You want to solve for y is equal to 0. So you have 3 x plus 2 is equal to x if you add this expression on both sides. If you now x cannot be minus 2 because then you have to have 0 in the denominator. That is not possible. So x plus 2. And I think you can see that your x has to be equal to 1 actually here. Because if you have 1, 1 plus 2 is 3. 3 times 1 is going to give you your answer. And I don't think any negative solutions are possible, but let's just quickly check. So you have x squared plus 2x plus minus 3 is equal to 0. So that is going to be plus 3, 0. So x minus 3, that is the solution as well. x1 and x minus 3 are going to be your solutions. So if you put minus 3 here, minus 3 times minus 1 will also give you 3. All right. So that is your 2 points. Now we want to find dy by dx, right? Because it says find the gradient of the curve. Gradient of the curve, you use dy by dx. So d by dx of x minus 3 over x plus 2. And you can distribute this, right? You can write it as d by dx of x minus d by dx of 3. You can bring 3 to your front, x plus 2. And you can write this as x plus 2 to the power minus 1. So that is 1 minus 3 times minus 1, x plus 2 to the power minus 2. And any x tega, made, so you have to differentiate it again. And if you differentiate it again, you'll get 1. So times 1. So you get 1 plus 3 over x plus 2 squared. So now I want to substitute x is equal to 1. dy by dx when x is equal to 1 is 1 plus 3 over 9, right? 1 plus 2 is 3. So 3 squared is 9. So 1 plus 1 over 3 is going to be 4 over 3. And dy by dx when x is equal to minus 3 is going to be 1 plus 3. Minus 3 plus 2 is minus 1 squared is 1. So that is going to be 4. So that is going to be your 2 solutions. 4 over 3 and 4. All right. Find the coordinates of the point on the curve where the gradient is 0. So I have y is equal to x squared minus 10x plus 26 to the half power, right? That's just what the square root means. Now gradient is 0, so I need to find dy by dx. So that is going to be d by dx of this expression. So you bring your half to the front. Half minus 2 over 2 is minus 1 over 2, right? And then, ani x tega, made, so you have to differentiate it again. So now you get 1 over 2 square root of x squared minus 10x plus 26. And then you have 2x minus 10. And you can actually factor out the 2 here. So you get x minus 5 square root of x squared minus 10x plus 26. So now we need to solve for this is equal to 0, right? Your denominator can never be 0 for a fraction. So x minus 5, your numerator has to be 0. X is equal to 5. And it says find the coordinates. So I'm just going to substitute 5 here. So y is equal to 25 minus 50 plus 26. So that is just 1, I think. So you have minus 25 plus 26 is square root of 1, which is 1. So therefore, your coordinates are going to be 5, 1. So we are done. And question 7. Tiring. All right, so this is the last question. So you have this curve passes through this point. So first of all, let's just substitute this point in. So y is 1 when x is equal to 2. So you get this equation. 2b minus 1 is equal to a. That is equation 1. And now it has a gradient of this at this point. Alright, so we need to find dy by dx. Right, that is going to be d by dx of this expression, a over bx minus 1. You can take out this a, you get d by dx of bx minus 1 to the power minus 1, right? I hope this is clear. So now you have a, you bring minus 1 to the front, you have bx minus 1, but ani x tega made. So you have to differentiate it again. So you have minus a, bx minus 1 minus 2, and you have b from there. So you get minus ab divided by bx minus 1 squared, and that is equal to 3 over 5, right? Minus 3 over 5. So now you can cancel out the negative sign and you get the equation 5ab. If you multiply by 5 on both sides, it's bx minus 1 squared. Alright. So now, this value occurs when x is equal to 2. So let's just substitute that in. 5ab3, 2b minus 1 squared. Now, 2b is just a plus 1. So I'm going to substitute this in here. So a plus 1 minus 1 will just leave you with a. 3a squared. Alright. And now, I can substitute b to be half. B is just half a plus 1. So I can substitute this here. So I substitute 2b here, and then I substitute b here. So 5a and b is just half a plus 1 is equal to 3a squared. Alright, so I multiply by 2 on both sides. I get 5a times a plus 1 is 6a squared. And that is 5a squared plus 5a is 6a squared. And if you subtract 5a squared on both sides, you get 5a is equal to a squared. A squared minus 5a is going to be 0. So a minus 5 is equal to 0. Alright. So remember, a cannot be 0. Otherwise, this would just be 0. And the gradient would be 0 at all points, right? So a cannot be 0. So therefore, a has to be equal. A minus 5 has to be 0. So a has to be equal to 5. And now you can solve for b. You just substitute it here. You'll get b is equal to 3. 5 plus 1 is 6. 6 by 2 will give you b3 as your solution. And that is it for this topic.